Okay, here we are looking at the problem from 4.4, which was about Torricelli's law. Um, so he's the inventor of the barometer, and he studied uh, air pressure. And Torricelli's law is that if you've got a tank and you've got a hole, the rate at which the tank leaks, so the derivative of V is equal to some constant times the square root of h, the height. It's minus, right, because the thing is leaking. So in our situation, we've got a tank which is a cylindrical tank, and because of that, volume equals uh, pi r squared h, and we're told that the radius, that the diameter is 3, so that means the radius is 3/2. So we've got 9 pi on 4 times h. And so that means we can solve for this. We can get h equals 4v divided by 9 pi. And so Torricelli's law becomes v prime equals minus c times a constant. We can replace the height by this volume, and we see that everything is a constant except the v, so we can write it as minus k times square root of v, where k now is the old constant c times the square root of 4 on 9 pi. So the main upshot of this is that we can use volume instead of height. Because it's a cylinder, it's kind of like at each height, it's got constant area. So the value for K for this problem is, we're told that when the tank is half full, so when the height is 5, then the rate of change is -2. So it equals minus K. And what is the volume? The volume when height is 5, then is 45 pi on 4. And so we go ahead and we can get rid of the minus signs, and we get K is equal to 2 times the square root of 4 on 45 pi, and that is around 0.336. Okay. Next, we're told to use Excel to find the volume after 12 hours and after 24 hours. So I set up a file called Torricelli, and I include that in the homework solution file. And so if you go ahead and do that, you'll see that if you do something like make a table like delta T, what is the volume at 12 hours, what is the volume at 24 hours, and we might as well do part D as well. What is the time to empty? So when delta T is 1, it says it took 15.14, 3.27, and it took 32 hours to empty. Whereas if we use 0.1, we get 15.39, 3.60, and 34.9. And so these are pretty good. They look like they might be stabilizing. Well, let's have a look at 0.01. We've got 15.41. So V12 is definitely stabilizing. 3.64 and 35.29. And so we might just do one more. We get 15.42 3.64, and 35.34. And so we can see that if we say after 12 hours, there's 15.4 cubic feet, 3.6 cubic feet at 24 hours, and it takes around this many hours to empty. Okay. Right, so now we use the differentiation rules to show that if we have V equals K squared on 4C minus T squared, that will satisfy the equation. Well, the derivative of that is K squared on 4, oops, sorry, the squared is here, times 2 times C minus T times minus 1 by the chain rule. And so we see that that equals K squared over 2 minus K squared over 2 times C minus T. Whereas if we look at minus K times square root of V, what do we get? We get minus K times K on 2 times C minus 2. And we see that two things are exactly the same. So it does satisfy the equation. And what is the interpretation of this function? Well, it is that C is the time to empty the tank. Right. And then we can look at it the other way, where we can actually use our initial conditions to solve it. So in our initial conditions, we know that V of 0 is K squared on 4 times C squared, and that has to equal the volume. And right, the volume we saw was 45 pi on 4. We know what K is, and so we can go ahead and solve that. And if we go ahead and solve that, we see C equals 35.34 as we found. And so that agrees with what we did in our Excel file.